Hello, boys and girls. Once again, it is Mr. Nshindano, and I'm going to take you again in science for Standard 6. Today, we are going to be talking about light. We'll talk about light. Let's go to what we are going to achieve today. At the end of the lesson, pupils should be able to describe the characteristics of images formed by a plane mirror. 2, discuss some applications of deflection. 3, describe refraction of light. And 4, demonstrate diffraction. These are our lesson objectives for today. Right, boys and girls, what is light? Imagine you are sleeping, you switched off the lights, you wake up and it is just dark throughout. How would you feel? I'm sure some of you are very, very scared. That is the reason why some of you cannot sleep without the lights on. So what is light, boys and girls? Light is a form of energy. Light is a form of energy that helps us to see objects. Light helps us to see objects. I said, imagine the room is very dark. You can't see anything. So unless there is light, that's when you can see where you have put your items. So light is a form of energy that helps us to see objects. How do we see? Light from the object will come to our eyes and then we are able to see. But when light falls on certain objects, it is scattered. Others, it's deflected. And we are interested in deflection. So, we'll talk about deflection later on. Light sometimes can be blocked, or light can pass through a material, or we can just see small light at the end, or we can see light that is disturbed. We are going to talk about transparent, translucent, and opaque objects. What is a transparent object? You know, when you are in your classroom, you are able to see outside. Why? It is because you are able to see light that is coming from outside, and you see the objects that are outside. So that material that is put there where you are able to see, like a glass pane, that is called a transparent material because you are able to see through that material. Then we have a translucent. You have seen some glass panes that are found in, let's say, in the bathroom. Are they clear? No, they are not clear, but, you know, if there is light inside, you are able to tell, to say, there is light inside, but you can't see exactly where is the source of light, but you are able to see, to say, There is light there, but it is not very, very clear. In other words, the light is disturbed. So this type of material is called translucent. A material like the glass for the bathroom window or bathroom window pane, it is called a translucent. And the third one is an opaque. An opaque is a material that blocks light completely. For example, if I have this light here, this light, as you can see, I'm able to see deflection on the screen, but the moment I bring my book, the light is blocked. Now, this material that is blocking the light is called an opaque. It blocks the light completely. You can't see anything. So this is called an opaque object. It does not allow us to see through. We talked about diffraction of light. What do we mean? Or what do we understand? What do you understand by diffraction of light? Diffraction of light is the sending back or bouncing back of light rays which fall on a surface like a mirror, the surface that is shine, that is smooth like a mirror. We call it diffraction. Let's take an example. I've got this mirror here, and there is this light here. So when this light shines on the mirror, the light is bounced back. I can see light at the back. So that light there has been reflected. So this is what we call deflection of light, bouncing back of light. All right, let's look at our diagram. Let's say this is now the sun, and we have got light that is coming from the sun. As you can see, it is deflected. This is light that is coming, and then it is deflected. When light is coming from a source, there are three terms that we are going to use. The beam that is coming from the light source is called an incident ray, an incident ray. And then when it is bounced, it is called a diffracted ray. But there is one that is in the middle and we cannot see it. It is an imaginary line which is called a normal. So it is called a normal. This happens when light bounces back from a mirror, as I just showed you. The incoming ray is called the incident ray, and the outgoing is called a diffracted ray. Now, we cannot talk about light without talking about the mirrors and the images that the mirrors will also make. So we are going to look at the mirrors and images. What is an image? An image is simply a picture of something, okay? An image is simply a picture of something. Now, there are two kinds of images. Do you know them? Yes, we have got real images and virtual images. Real images and virtual images. What do we mean when we say real and when we say virtual image? A real image is something that we can show against a screen or wall or on a piece of paper like a photograph. For instance, if I used this camera, to take you a picture, you are going to have a picture, all right? So what I'm taking a real image. Then we have a virtual image. A virtual image is not real. It is not a real image, and we can't see it on the screen. We can see it, but we cannot show it on a screen or wall or on a paper. We are going to look at the characteristics that are made using the mirrors, or that are formed by the mirrors. 1. The image is formed behind the mirror. What do we mean? The image is formed behind the mirror. As you can see, I'm looking myself into a mirror. My image it looks like it is behind. My image is like it's behind the mirror. So, the image that is formed by a mirror is always behind the mirror, always behind the mirror. Since it is behind the mirror and it is a virtual image, you cannot touch it. You can't touch it. The image is always virtual and upright. What does that mean? Virtual and upright. What do you understand? Virtual and upright. It simply means the way the teacher is standing and looking himself in the mirror, that's the way it is being shown. As you can see, the teacher is standing upright, and the image also that is formed behind the mirror is upright. Not upside down, but it is upright. And this is what we mean. The image is virtual and upright. Because the image is upright, we say it is an erect. The image is erect. The image is the same as the object. Boys and girls, your teacher is looking himself in the mirror. The image, which is myself, the object, which is myself, and the image that is being formed are the same size. When I look at myself in the mirror, I don't see myself small. I'm looking at myself in the mirror the same way I am, as big as I am. The images are formed as far behind the mirror as the object in front of the mirror. Boys and girls, what do we mean? What do we mean? Let me explain. When the teacher is standing, let's say 1 meter from the mirror, the image that is formed is also going to be seen like it is 1 meter from the mirror. This is what we mean here. The image is literally inverted. Interesting. Very, very interesting, boys and girls. The image is literally inverted. What does that mean? Once again, this is what it means. Have you seen my hand? What can you say? This is my right hand. What happens in the mirror? What happens when I'm looking in the mirror? As you can see, my right hand in the mirror has turned to be my left. Let's see what we are talking about. As you can see on the image, there is the teacher with the right hand, and the teacher is looking himself in the mirror. The right hand in the mirror would look like it is the left hand. This is what we mean when we say it is literally inverted. This is very, very important. We shall look at the importance of this. Right. Using the deflection. Is deflection important? Very, very important, boys and girls. In case you didn't know, deflection is very, very important. In which ways? Deflection is important in the following ways. One, we use the mirrors to see ourselves. Let me pick my mirror. I'm able to see myself. Okay? Before we go to school, I'm sure each and every one of us, we look ourselves in the mirror to see how we are looking. One can hold a mirror at an angle to see around a corner. I'll be explaining this using a diagram. One can also use what we call a periscope to see over the heads of people. You know, periscopes are also used in submarines. You boys and girls, you know what a submarine is. With me here, I have an example of a submarine. It moves under the water, under the ocean, but it only leaves a small part on top. I'll be explaining this. Now, this is a periscope, boys and girls. A periscope uses two mirrors. There is one mirror on the top and then the other down. These two mirrors at an angle of 45 degrees. They are at an angle of 45 degrees. Now, a periscope, I can use a periscope to see. Imagine I'm in a wall fence, right? And I can't see and I cannot climb here. So I can use a periscope to see what is happening on the other side. Now, this is how it works. We have light that is coming from, let's say, a tree. It meets the first mirror, which is at an angle. We were talking about deflection. Light is deflected down, and then it meets another mirror that is at an angle of 45 degrees as well. What happens? Again, it is deflected to the teacher or observer and can see what is happening on the other side. Now, this is what happens in a submarine. As they are underwater, they are able to see whatever is going on outside, and they'll be safe. So this is one way of using deflection. Right. I'm going to introduce one more words that we use when we are talking about light. We said diffraction is the bouncing back of light. Now, we are going to talk about refraction. Boys and girls, can you observe? There is a difference between diffraction and deflection. This one has got an R. And we read it as diffraction. So what is refraction? Diffraction is simply the bending of light. Bending of light. We are going to do a bit of experiment, very, very simple experiment. You can try it at home because it is not involving any chemicals. So let's look at our experiment. We are going to have a glass filled with water and then put a pencil inside that water. I want you to observe what is going to happen. Here's my glass of water and a pencil. When I put it inside, wow, and I look either from the top, it's like the pencil is cut. It's like the pencil is broken. What we are seeing here is what we have here. This pencil looks like it is broken, exactly what I'm seeing here. You can try this. Get your pencil, get a glass, put water, and put your pencil or a spoon. If you are making tea, put your spoon there. You are going to see that the spoon looks like it is cut or it is broken. Now, what we have here is what we call refraction. So, diffraction is the bending of light. The bending of light. The pencil looks like it is broken because light is bending. What makes the light to bend? When light comes from a lighter medium into a denser medium, it bends. And this is what we are seeing here. Air is a light medium and water is dense. So light is going to bend. All this that we have here is diffraction. Boys and girls, what causes diffraction? Diffraction is caused by when light travels from air into water and it slows down. You know, light travels at a certain speed. So when it enters into water, it slows down. And this slowing down causes the light to bend. It's like you are throwing a stone in water. It comes at a higher speed. When you throw it in water, then it will be going slowly. This is what happens with diffraction. When light enters a more denser substance, it bends towards the normal line. Boys and girls, we talked about the incident ray, we talked about the refracted ray, and now we are talking about the normal. Look at the normal. So when light is coming from air, it goes into water, it bends towards the normal. Now, there are people who are very skilled. They catch fish using spears. Do you know a spear? Yes. Ask Mama and Papa. They will help you with that word. They use a spear. So, as you can see, when you are looking at the fish underwater, it looks like the fish is here, but this is not the position of the fish. Actually, the position of the fish is close to normal. So it takes a skill for the fisherman to spear the fish. Then we have what we call a mirage. Boys and girls, not a marriage, but a mirage. What is a mirage? I'm sure you have been traveling with Papa, with Mama, or anybody else on a very hot day. As you travel on a hot day, in front of your car, you would see like there's a pool of water. When you reach where you were seeing like there's water, you find water has disappeared. And you see it again in front of you. You reach there, you find water has disappeared. So that is what we call a mirage. It is an illusion, like something is there, but it is not there. Now, this is something like this, boys and girls. As you travel, you are able to see like the car in front is, there is water. But actually, this is not water. This is what we call a mirage. And I'm sure you have seen this, boys and girls, on a very hot day. All right. We have instruments that use diffraction. Instruments that use diffractions. We have got the lenses. With me here, I've got glasses. These glasses I can put on, and they are using a lens. This is a lens, okay? Now, there are two types of lenses. There is a concave and a convex. Concave and a convex lens. This is an example of a convex lens. It is thick in the middle and thin at the end there. So when light is coming from the source, when it enters into a lens like this, it bends. Remember, we are talking about refraction. It is the bending of light. So light comes, then it bends. As it is coming, it bends, and it forms what we call a focal point. The teacher is able to put on the glasses so that he's able to read properly. So by the time the rays meet here, then teacher is able to read properly. The hand lenses, I'm sure you are playing with these at home. These are examples of a handheld lens. A handheld lens can be used to magnify or to make something that is small to look bigger. I'm sure you have these ones at home where you try like that. As you can see, some of you are going to be doctors. Some of you are going to be working in the laboratories, and you'll be working with these instruments. So this is a microscope. A microscope uses also refraction. You can see, boys and girls, there are those that are interested in seeing the stars at night. So we use a telescope. We use a telescope. As you can see, a telescope is used to look at the moon, the planets, and the stars. Okay? Some of you have these ones, and you use them at night to look at the stars and then the moon. We also have what we call the binoculars. we use the binoculars to see, especially if you go in a game reserve and you want to see the animals that are very far from you, you use the binoculars. Right. Boys and girls, we are going to have our exercise. And our exercise today, you are going to have 2 questions, and these 2 questions is divided into 2 as well. Question number 1, explain what each of the following words mean. A, opaque. B, transparent. C, translucent. Question number 2, name any 2 instruments you have learned that use A, deflection of light, B, diffraction of light.
Friends, unfortunately, we have come to the end of the lesson. That's all that we had for you today. Thank you so much for joining us. And like I always say, if you would like to continue learning something new while having so much fun, all you have to do is join us same time, same place. My name is Lokwamla Lapata, and you were watching Primary Catch Up. Remember to stay safe and stay learning. Bye, friends.